Hey, this is Mr. Hansen. I wanted to look at another way to solve a system of equations with you today. This is called row operations, and it involves turning your system of equations into a matrix. And you might be asking, why do we have to use another way to solve a system of equations? We've got elimination and substitution and graphing. They work pretty good for us, and that's true. This way helps you kind of start to think the way a computer would solve equations. And if you kind of understand this method, you understand what a calculator or a computer is doing. Also, it helps you with larger systems of equations. We've worked with 2 equations and 2 variables. You could have 3 equations and 3 variables, or 4 equations and 4 variables. And it might actually be easier to use this row operations rather than elimination or substitution. So let's go ahead and get started. Before we actually work with a matrix, I need to just remind you of some rules, and we're going to look at these rules in terms of the actual equation, and then we'll do them with the matrix. So number 1 says you can multiply both sides of an equation by the same number. So look at this bottom equation here. I'm going to rewrite this bottom equation. I'm going to write 2x plus 2y. I'm going to multiply it by negative 2. Negative 2x minus 2y equals negative 8. So these 2 equations right here are going to give you the same exact solutions. If you plug numbers in for x and y, they'd be the same for the red equation as they would be for that black equation. So we can use the first black one and the second red one to solve a system of equations if we wanted to. And let's just do that. I'm going to put that first black one over here. Let's do it in black still so we can kind of see the original. 2x plus 3y equals 10. And you might remember from our lesson on elimination that you can add 2 equations together, and the sum of their equations is going to be a new equation that would also give you a solution to the system of the original equations. So let's just sum these up and see what we've got from here. So this is rule number 2. You can add 2 equations together and replace one of the original equations with this sum. So let's add them together, and since it's a new equation, I'll do this in a different color. 2x minus 2x, that's 0x. 3y minus 2y, that's y. And 10 minus 2 is 8. Or 10 minus 8 is 2. So there you have it, y equals 2. And that equation can work together with the black equation, and so the black equation and the green equation could work together, the black equation and the red equation could work together, or the red equation and the green equation could work together to help you kind of finish things off here. So if I wanted to, and from here you'd probably just substitute in for y and get an answer for x. Okay, last thing, this is just a minor thing here, but number 3, you can swap rows. It doesn't matter if I write the system like this here, or if I write it like this. That makes absolutely no difference which row is on top. So these are kind of the 3 rules that we're going to use to solve a system of equation using row operations. So let's see what we can do here. Here's my equation, my system of equations I want to solve. To the right, this is what I want to end up with. In the end, I want 1x plus 0y equals a number, and 0x plus 1y equals a number. This is where we take the variables out and we write what we call an augmented matrix. This is pretty easy. So I just write 2, 4, 10, and 3, negative 2, negative 1. We basically just took the variables right out of that, and now we're just dealing with numbers. Okay, from here what I'm going to do is I'm going to go ahead and solve this, and as I'm doing it, I want you to kind of just think about the rules that we talked about a minute ago and see if you can understand what I'm doing. So I'm going to work on this silently, and hopefully as I'm doing it you can kind of see, and then we'll come back and talk about what we've accomplished here. So the idea is we want to get something that looks like this. We want a matrix that looks like this, and maybe a number there where that blank is, and a number there where that blank is. That's kind of what we're working towards. So we want to get some zeros and some ones. And let's just go ahead and start. I'm going to try getting some zeros first. So take a look at what I'm doing, see if you can figure it out. Okay, this is kind of where I wanted to end up, right here. And then, so there's a 1 that goes in here and a 2 there. And if we turn that back into an equation, it'd be 1x plus 0y equals 1. And 0x plus 1y equals 2. And we can say x is 1, y is 2. There's our ordered pair right there. So let's kind of just talk through this process and help you kind of see what's going on. First step, we got rid of all the x's and y's. We made an augmented matrix. So that was step 1, augmented matrix. Step 2, to get from the first augmented matrix to the second augmented matrix, we times the bottom row by by 2. So negative 2 times row 2 gives me a new row 2. And this is common matrix notation like this. Okay, now to get from the second to the third, we added the first and second rows together, and we replaced the second row with the sum. So row 1 plus row 2 gives me a new row 2. And the reason we did that is because it helped us get that 0 right in there. And that was, I always find it easier to get your zeros first before you get your ones. Okay, let's take a look at the next one. So here it looks like we times row 1 by negative 4. And so we're kind of setting ourselves up for another 0 in the top left corner there. That's what we're doing. And then it looks like we added row 1 and row 2, and then so row 1 plus row 2, and then we got a new row 1 out of that, and that gave us our new 0 there. Once you have your zeros, your ones are really quite easy to do. We for this one up here, we did a row swap, so we went from row 1 to row 2 being on top, and from here to here we times everything by 1/8. So 1/8 of row 1 gave me a new row 1, and then we times everything on the second row by negative 1/16. So negative 1/16 times row 2 gives me a new row 2, and then we have our answer. So this was a little bit laborious, but this is maybe how a calculator would probably not deal with variables. They're just making computations. So this might be how a calculator would, there would be an algorithm inside the calculator that would work through the most efficient way for you to get the 1, 0, 0, 1 matrix, and then it would be solved for you. Now let's say, what if we had, just for fun, what if we had something like this? X plus 2y plus z equals 10, and 3x minus 2y plus 4z equals 12, and 2x plus y minus z equals 6. This kind of problem would need we need to solve for x, y, and z, so you might have something that looks like this, and this would be your end goal, something like this. And then you would have some numbers out here for x, y, and z. And it's really the same process. And when you get into three variables and three equations, row operations might actually be a little more helpful to you than substitution or elimination. It's a good way to help you keep track of what you're doing. Thank you for tuning in. I hope this helped you understand how to use row operations. You may have noticed that there's a lot of similarities between row operations and elimination. Really, you're just doing elimination without the variables. Have a good day. Thanks again.